If we're going to learn whether we're alone in the universe, we have to see how we got to this point of being able to understand the universe. So in this first lecture, we'll look at civilizations and culture. How long did it take for us to get to this current capability? Astronomy is an important subject, but it's not always been a part of the human landscape. Paying attention to the stars started to become very important when humans had to survive by keeping track of time and by navigating. So it is essentially the oldest science. Another large change came with the advent of agriculture. But understanding our place in the universe is a uniquely human attribute. If we're thinking of intelligent life in the universe, there could be creatures like orcas or dolphins. We believe certain marine mammals on our planet are intelligent, possibly even sentient, but they live in a marine environment where understanding the universe or observing the stars is not possible, nor do they have the ability to manipulate objects and develop technology as we did. So we recognize at the outset that in this subject and in this part of the course, we're in danger of falling into anthropocentric thinking or arguments. That is to say, arguing too much from the situation of our own humanity and our own capabilities, and then trying to project that out into the universe. With that as a warning, we can continue and look at how we got to the present day. One of the revolutions that happened that was important for humans to develop and in fact to start to grow in numbers from the million or so that inhabited the planet for many tens of thousands of years was agriculture. Early humans learned to tend crops and make artificial caches of food rather than what they could just find and gather about 12,500 years ago. The ability to gather food reliably and routinely meant they no longer had to be nomadic. So humans could live in one place. With fixed civilizations, even if initially it's just simple farming communities, you can gather artifacts, you can store food, you can develop more resources, and you can grow your population. All of these things happened with humans around the world about 12 or 13,000 years ago. There's good evidence that early hunter-gatherers, nomads, were in small groups, 30 to 50. That's probably as many individuals as could hang together and protect themselves and gather enough food to survive. With the development of agriculture, the social units started to grow. Obviously, there were villages and eventually towns, and so societal structures began to emerge. And with those societal structures, and the fact that people didn't have to move around constantly from day to day, people began to have belongings, and individuals began to cultivate particular lifestyles or skills that they would contribute to the culture. This differentiation of abilities, skills, and even jobs among early humans fostered a much larger and more complex civilization. But the beginning of agriculture was probably the key in this transition, because agriculture depends on understanding the seasons in most parts of the world. And understanding the seasons requires keeping time. And keeping time requires a calendar, which depends on astronomical observations. So as soon as agriculture became important for human culture, astronomy became essential. Successful harvest and survival now depended on the stars, and detailed study and dedicated study over a period of time was required to fully understand the motions. Even though these cultures did not have a sophisticated or three-dimensional sense of their position in space, they were able to quite carefully observe the motions in the sky and use them to their advantage. Who were these early astronomers? These early astronomers were not, of course, scientists in any conventional sense. They were just dedicated individuals and groups of people who began to formalize the study of celestial motions. As soon as there was a written language, they began to keep records, and we see these going back to Babylonian times 5,000 or 6,000 years ago. So with the first fixed civilizations came astronomical records and timekeeping and the ability to master agriculture. Eventually, astronomers expanded the scope of their studies and began to wonder about other objects in the sky. Obviously, some of these objects had mystical or religious significance. The transition to a settled society was what allowed astronomy to develop eventually into a science. We can see the mark of astronomy in ancient cultures around the world. It's fascinating because each culture, independent from the others, has had the need for astronomy and for timekeeping and for calendars, but they've expressed this need in different ways, in ways that are unique to their own culture. Again, because some of these cultures have no written record, we have to be careful not to project our modern values or our modern sense of what science is onto these ancient people who were using astronomy for essentially pragmatic reasons. But the sophistication of their timekeeping and their calendars is striking. In fact, the Babylonians had a calendar 3,000 years before Rome that was more accurate than any calendar until the Julius Caesar calendar around 0 BC. So there was some strikingly sophisticated work going on, detailed observations, and probably the astronomers in these cultures had very high status and were valued and esteemed even at the top levels of the royalty of these cultures. Entire cities were built around astronomical structures, especially in Meso and Central America. The amount of manpower required to construct some of these entities, observatories essentially in the ancient world, is phenomenal and shows how important these structures were. For example, in these pictures, we can see Chichen Itza, which looks like an observatory. Of course, it was not in any modern sense. There's no telescope there. But in that culture, it was used for observations of Venus, which was the most important object in that culture and that religion. Machu Picchu is another example of a civilization that built an incredible structure on a high mountaintop in the dense forest of Peru, and many of the alignments there have an astronomical significance. Around the world, we can see many examples. Stonehenge, already mentioned, is a primordial example of a structure used for primarily ceremonial purposes, for gathering together the clans from some large part of southern England, but it has an astronomical function too, primarily as a timekeeping device, to represent the solstices and the equinoxes, to know how to run agriculture, and with the winter solstice to celebrate the return of the sun to higher angles in the sky. But such things have been found around the world. Here in a Babylonian fragment, we see a comment on the appearance of Halley's Comet, centuries, millennia before Edmund Halley saw its return using Newton's law of gravity and calculated its orbit and thereby understood it as a celestial object. The Babylonians also gave us another relic that continues to the present day. They developed our divisions of time with 60 minutes in the hour and 60 seconds in the minute, which were mirroring the angular measurement system, which has 60 seconds of arc in an arc minute and 60 minutes of arc in a degree, and then 360 in a circle, which is 6 times 60. The Babylonians had a counting system that was not metric. It was based on factors of 60. And the fact that this counting system persists to the modern day, 5,000 years later, is an amazing sign of how the imprint of early cultures can persist through the mists of time. The early astronomers tried to go beyond simple predictions, and that marks one type of transition towards a more scientific way of thinking. Because they were not content simply with observing what happened and repeating it and recording it endlessly as a predictive mode for agriculture, they were curious as to what was going on. What were these luminous objects in the sky, these moving objects in the night sky, the ones that moved differently from the stars, the planets, for the Greek word for wanderer? What were they like? How far away were they? Were they anything like terrestrial material? Were they actually planets? Such speculation existed even thousands of years ago. But mostly, and to most people, these were unknown phenomena, and people had more earthly concerns, like where they were going to sleep and what they were going to eat the next day. And so it's only really with the emergence of modern science in the Greek civilization 2,500 years ago, with Pythagoras and Aristotle and Plato, that we have the questioning of an abstract conceptualization of what's going on in the sky, a model for the heavens that goes beyond practical significance to wonder what they really are, these objects that move in the sky. A neglected part of this story comes from Arabic astronomy. Astronomy flourished in a time when Europe was in the Dark Ages and in medieval time. Essentially, science stood still in Europe for some large chunk of time. After the fall of the Roman Empire, the Romans didn't actually add too much to Greek knowledge. The writing that had been put in place in the Roman time was essentially lost. And in the Dark Ages and in medieval times, the only places of learning were a few scattered monasteries. Meanwhile, the Islamic Empire was flourishing and spreading throughout Europe, even far to the north and down through the northern part of Africa. This culture esteemed science and invented many important concepts and aspects of modern mathematics. The astrolabe, for example, was invented by Islamic women scientists. And there was a mathematician who also did astronomy who described for the first time Andromeda Galaxy and the Large Magellanic Cloud, although at the time he did not know they were galaxies. There were various ideas in optics that were also important. One Arab astronomer, the father of optics, figured out how we perceive light, because the Greeks and Romans actually thought that light emanated from the eye and bounced off the object you saw. The Arabs were the first to realize it was the other way around. The light entered the eye from the object we see. So the mathematics, the optics, and the simple astronomy that came from the Islamic Empire over a period of 600 or 700 years was very important to the history of astronomy and to the history of human ideas. For millennia, we've been working to understand astronomical phenomena, and examples of these observatories are found all over the place. The one in the middle is Uraniborg, a very important observatory of Tycho Brahe. Brahe was a contemporary of Kepler, and he was the one who would make the best naked eye observations ever in history from 25 years of systematic observations on this island off the current coast of Sweden. Uraniborg was a place where he observed the motion of Mars, and with Kepler applying math to Brahe's motions, elliptical orbits became inevitable. This was the beginning of the overthrow of the geocentric model. So these observatories have been built throughout the ages for hundreds and for thousands of years, and gradually our knowledge has advanced. For humans to wonder whether we have counterparts out in the universe, thinking of their place in the universe and exploring it, we have to see how we got to this point. The history of humans is a history where most of the time we were hunter-gatherers for tens and hundreds of thousands of years. Only with the advent and invention of agriculture could humans settle into fixed civilizations. At this point, astronomy became essential. It became essential for regulating time, keeping a calendar, and running agricultural systems that could feed people. Astronomy gradually became more and more important through the centuries and millennia.